In this video, we're going to look at two special cases that come up when we're graphing linear equations. The first case we're going to look at is a horizontal line. When you think of a horizontal line on a graph, like the horizon, it would go straight across. So horizontal lines would be flat lines straight across the graph. So the graph of the equation of the form y equals b, where the y-intercept is the point 0b. So that's the definition of a horizontal line. It's the graph of the equation of the form y equals b, where b is a number. So here's an example, y equals -2. So if I went to y equals -2 and I said the y-intercept is 0, -2, because for a horizontal line, the y-intercept is always that number. I could go down and plot that point, 0, -2. And since it's a horizontal line, I know the line is going to go straight across like the horizon, right through that point. So I could draw that line through my gargantuan point. I kind of got carried away with my point there. And that is a horizontal line. Now you'll notice that I could go to any point on that line, any place I wanted, and this point has the coordinates 3, -2. And I could pick a point over here. This point would have the coordinates -1, -2. But you'll notice the y value doesn't vary. No matter what point I pick, the y value for that point, the y coordinate, is going to be -2. So the equation of a line that is horizontal is always y equals a number. In this case, y equals -2. So this is a special case. You'll notice that the equation doesn't even have an x showing up in it, just a y. Y equals -2 is a horizontal line. If I had a different horizontal line, like I was going to graph y equals 5, you could think, well, that is going to have a y value of 5. So I'll have a y-intercept of 0, 5, and it will go across horizontally each point on this line having a y-coordinate of 5. So if I was going to graph the line y equals 5, it would be a horizontal line with y-intercept 0, 5. So let's look at one other special case. And you might guess, if we're looking at horizontal lines, the other special case is going to be vertical lines. So vertical lines are lines that go straight up and down. Oh, and I see that I've done something funny with my graph here. Let me fix this. This should be a +5, +5, -5, -5. There we go. Okay, so when I'm looking at this one, a vertical line is the graph of an equation of the form x equals a, where the x-intercept is a0. Okay. So instead of y equals a number, a vertical line has a formula or a equation x equals a number. So the example I want to look at is x equals 4. So if I look at what I know about a vertical line, I know its x-intercept is going to be 4, whatever this number is, comma 0. So I can find that point and graph it. Here's 4, 0. Since it's a vertical line, vertical straight up and down, I know I'm going to graph my line straight up and down. And there's the graph of the line x equals 4. And notice, no matter what point I pick on this line, the x-coordinate is always going to be 4. Doesn't matter what point on that line, it will have an x-coordinate of 4. So x equals 4 is a vertical line that has an x-intercept of 4, 0, and every point on that line has an x-coordinate of 4. So if I wanted to do another vertical line, if I was going to graph x equals -1, I'd say, well, here's my x-axis. Here's where -1 is. So here's my x-intercept, -1, 0. And now I can draw that vertical line, x equals -1. And at every point on that line, the x-coordinate will be -1. This doesn't specify what the y-coordinate is because the y-coordinate can be anything. There's lots of different y-coordinates, but there's only one x-coordinate, -1. So the equation of the line, that's a vertical line, doesn't have a y in the equation, it just has an x. X equals -1. So horizontal and vertical lines are two special cases that we'll deal with when graphing lines.